Hello, my name is Mitya, and in this tutorial we will go through Lightact's audio visualization features. What I have here is basically a audio visualization project called audio visualization. The only difference is that I've saved it into a file so that I could import audio asset, so the audio file that the project is going to react to. Okay, so if I look into the assets tab in the audio section, you see that I've got a audio file imported. And if I press play, in a few seconds, the file will start playing. And it's all basically done in this layer called FFT, which means Fast-Fourier-Transform and render. If I open it, we'll just go through it. So you understand how this is all done. So first, you've got a audio file reader node, which has a source. We have to select which source, the audio source you want to play. I have it connected to audio player. And in the devices window, I've got audio input, which is the microphone. We don't actually need it right now. But if you wanted to create an audio visualization, you would just connect audio input reader to the FFT node and the audio player node. But now we just have a visualization based on the file. So in the devices window, I've got audio input, as I said, and I've got audio output, which is set to my headphones. So let's open this again. So audio player doesn't really have to be here. It's just for me or for you, for that matter, to hear where in the file you are at the moment. So this is the most important node called FFT. The FFT stands for Fast-Fourier-Transform, and it's used. It's basically a standard to do a spectral analysis on audio files or even images and so on. What FFT does is basically it analyzes audio file and it splits all the frequencies into bins. So here you can select into how many bins you'd want it to split. So I've selected 32. And what it outputs is an array of floats. That's why these 3 dots are here instead of just 1. And the length of this array is the same as the number of bins. So the index, the item at the beginning of an array will correspond to the bin 0, the second one to bin 1, and so on. The lower the item in the array is, the more it corresponds to the base of the audio. So the higher numbers in the array, the higher indexes in the array, correspond to the higher notes and the lower ones to the lower notes. Here, what I have is a node which basically sums up all the elements, because in my visualization at the moment, we just want to know basically the volume of the audio. We don't want to create some effect for the bass and another one for higher notes. Float reader is just for me to know what's happening in the file, if everything is done correctly. And here we save this variable into a variable called, into a variable called FFT sum. Great, and let's go now to the other layer, which is called 3D scene. And if I open it, we have a camera, which is what we always need whenever we do a 3D rendering. And we've got a render 3D node, which is also something that we always need. And then we've got a particle system. If I open it, you see that I've set the max number of particles, which is the loop is important, and so on. There are separate tutorials for the particle systems. And I've set the sphere. So what we have is we get the FFT sum variable, we multiply it, we interpolate it so we don't jump, so the changes are a bit more gradual, and we have another float reader here, so we see what's happening. And then what we do is we adjust the radius of the sphere. You can adjust the speed with which the sphere is adapting to the overall volume by playing with the speed of the interpolation. So if I put, say, 5, then the speed of the interpolation is much slower. The other thing I wanted to explain also is this one. The margin property in the FFT node basically allows you to analyze either before the time of the current time the audio file is at based on the transport, or after it. So if in some case your visualization is a bit behind the sound or a bit before the sound, you can play with the margin. Usually the values are going to be very slow, and the effect will be as if you corrected the offset of the visualization.